Given a string and an integer k, count every non-empty contiguous substring where at least one character appears at least k times inside that substring. Return that total count. Example 1 with k equal to 2. Substring ABA has 2 A's, so it qualifies. Extending to ABAC still has 2 A's. The full string ABACB also has 2 A's. Starting at index 1, BACB has 2 B's. 4 valid substrings in total. Example 2 with k equal to 1. All substrings are valid because every character appears at least once. The output is 15. We extend the right boundary until some letter reaches k copies. At indices 0 and 1, each letter appears only once. When the right boundary reaches index 2, the window contains a second A. The count of A is 2, which satisfies the rule. This window ending at index 2 is valid. We need at least k copies of some letter inside the substring. Once the window holds 2 A's, moving the left start further left cannot drop that count below k. Both A's at indices 0 and 2 remain inside. Any substring ending at index 2 that starts at index 0 or further left is still valid. To find how many starting positions are valid for the current right endpoint, we slide the left pointer forward to test our limits. When the left pointer passes index 0, it leaves the first A behind, dropping the count below k and breaking the window. Index 0 was the exact boundary. Every starting index before the left pointer is valid. So index 0 works, that is one substring ending at 2. We only have one valid start here. L sitting at 1 is that count. We add 1 to our running total. We advance the right pointer to index 3 and take an AC. Nothing new reaches k, but our earlier pair of A's still covers this endpoint. L does not move. Same one valid start at index 0, we harvest again and the total becomes 2. The right pointer reaches index 4 and B now has 2 copies. We slide L forward until the window breaks at index 2. That leaves 2 valid starts, indices 0 and 1. We add 2 more and land on 4 valid substrings. We kick off by pinning left and right at index 0, with an empty frequency map and our substring total at 0. The right pointer sweeps forward, logging each letter into the map. At index 2 we pick up a second A, the count hits 2 and we have our first matching window. Now we run the contraction loop. L steps past index 0, evicting that first A. The count drops to 1 and the window breaks. Index 0 was our minimal edge. Valid starts sit to the left of L, left is 1, so we add 1 to our total. Our moves to index 3 with a C. The while loop does nothing, but the tail still counts, we add 1 again for a total of 2. At index 4, B reaches 2 copies. L advances to 2, giving us 2 valid starts. We add 2 more and return 4. N is the length of S and K is the minimum character frequency. Time is O of N, each index enters and leaves the window at most once as right expands and left shrinks. Space is O of 1, we keep a frequency map with at most 26 keys, the left pointer, and the running total. Helper, check whether any character in the map reaches frequency K. Scan every character stored in the map. If its count is at least k, return true. Otherwise return false after the scan. Count substrings where at least one character appears at least k times. Initialize left and total substrings to 0. Start with an empty frequency map. Expand right across the string. Increment the count of the new rightmost character in the map. while the helper still reports a character at or above k. Decrement the count for the character at the left edge. And advance left by 1. Add the number of valid starts, which equals left. Return the total substring count.